Good afternoon. My name is Zeratric. Today we are going to see applied physics. My ID number is 21951A05G2. I am from CSSC section. Today my topic is 3D nanocarbon interconnects. In this we are going to see introduction, scaling in integrated circuits, interconnects versus transistors, CNT and 1D interconnect structure, CNT graphene for all carbon 3D interconnects. This is semiconductor chronology. MOS field effect transistor planar technology. 32 nm gate with MOS device shown by IBM at 2007 VLSI meeting. The semiconductor industry believed that the 32 nanometer litho node will mark the end of the current planar IC technology. Intel moved to FinFET in their 22 nanometer chips in 2011, while TSMC, Samsung, and others did the same subsequently for their 16 nm by 14 nm technologies. On chip scaling driven by Moore's law, doubling doubling number of transistors every 2 years, Moore in 1975, enabling more functions, reducing cost on chip interconnects becoming limiting factor for performance and reliability. Effect or end of Moore's law and much of the claimed gain is density is offset by the fact that much of the new circuits must be devoted to error correction, scaling ends. This is the graph of Intel CPU trends. Effect of scaling on interconnect reliability. Current density approaching EM limit of CU interconnects, voids formed, causing failure of interconnects. Alternative interconnect materials and structures. Nanocarbons as potential replacements for CU. Electromigration resistant, current carrying capability 108 amps A by centimeter square. Long mean free path, high mobility and near ballistic transport. High thermal conductivity 3000 watts by kilometer. CU 400 watts by kilometer. Contact resistance challenges. They are part of A and B. All carbon interconnects 1D to 3D. CNT as local vertical interconnect, graphene as horizontal interconnect, and or active channel material, extension of superior nanocarbon properties to 3D integration, sp2 bonding for high electrical and thermal conductance. There are 0D fluorines, 1D carbon nanotube, 2D graphene, 3D graphite. CNT bias objectives. Comprehension characterization of CNT bias with line widths approaching those used in current technology node, development of technique to extract contact resistance of CNT wires with line widths down to 40 nm, assessment of CNT wire performance and reliability and compare with CU and W. CNT growth in 60 nm wires. Vertically aligned CNTs are grown in wires using Na catalyst in plasma enhanced chemical vapor deposition PECVD system. Areal density 2 into 1011 by centimeter square. Average CNT diameter 15 nm. Dielectric filling and polishing. To maintain CNT vertical alignment in vias and to optimize CNT metal interface at via top contact wide in a via filled with Al2O3. Atomic layer deposition of Al2O3 using trimethyl aluminum and water at a rate of 1 Armstrong by Cy. Analysis of CNT via resistance data. R via equal to RCR plus R probe plus R probe minus CR plus R probe minus CNT plus RCR minus CNT plus RCNT equals to RM plus RC plus RCNT equal to RM plus RCI by DCNT into W square plus rho CNT into H by DCNT into W square plus ACNT. RM estimated RM estimated by direct probing of CR underlayer minus 15 ohms. RCI is contact resistance of individual CNT log R via log RCI DCNT P rho CNT into H by DCNT into ACNT minus 2 into log W. CNT graphene test structure fabrication. CNT grown on graphene. It is shown as like this. Electrical characterization. ALD oxide filler to strengthen CNT forest. Exposure of CNT tips for probe contact. CNT graphene contact resistance. Extraction in progress. Ground probe fixed on graphene while bias probe lowered at small increments to ensure direct contact with CNTs. Nanoprobing enhances the probability of making direct contact with CNTs. CNTs grown on graphene using PECVD at 500 VDC. 1 volt at 1 volt and resistance results show conduction with higher overall resistance than that of plain MLG with bias probe probably making partial contact with graphite. CNT is not as well aligned as those again obtained using 800 VDC, but improved alignment over those with thermal CVD. Reduced DC voltage in PE CVD appears to preserve MLG underlayer. First principles study First principles study of CNT graphene. 112 atoms of CNT, 536 total atoms, 44 CNT radius equal to 0.524 nanometer, 192 atoms of CNT, 572 total atoms, 8,0 CNT radius equal to 0.626 nm. Graphical abstract. In this, we have seen this all like 3D interconnects CNT as 1D interconnect structure and all carbon 3D interconnect. Thank you for giving this opportunity.